All right, make sure I know how to use the click right. Megan, thank you for that introduction. Everyone, thank you so much for this opportunity to be here. I feel like a teenage fanboy at an MTV Awards or something like that. I'm like, oh my gosh, that's Colin Wright. Oh my gosh, there's Cher. Holy cow. And I'm just so shocked, and it's so cool. And then I'm up here on the stage in front of you, and I hope I don't wet myself. So, we'll pray that that doesn't happen. I really want to thank Kim and Marshy, thank you. This is the problem. I go blank on things a little bit, but thanks so much for this opportunity. This is really cool. And again, to get a shout out for Emma Hilton and get a shout out from Christiana Kiefer. I'm just beside myself with excitement here. I'm so beside myself, it's like there's two of us up here. Now, I will tell you, as an academic, I have way too many slides because I have to put what I'm thinking on the PowerPoint, or else I'll go off on a tangent. And maybe I start talking about hemoglobin and the importance of hemoglobin in transporting oxygen in the bloodstream. And then next thing you know, I'm talking about World War Z and the zombies in The Walking Dead, and can zombies run or walk, and how long they can go without a meal. And so I've got to keep it very organized and concise on my PowerPoints here. I want to just tell you a little bit about myself that helps me feel more comfortable with speaking with everyone. So my wife, Amber, there, she's a rock for me. She's my inspiration. I definitely married up. And if it wasn't for her, I wouldn't be where or who I am. And she's also really good at helping me come back to reality. Talking last night about how sometimes I get in these deep dives looking in the research on this. My wife will come up and say, let's go for a walk. All right, so it's really nice to have that. My oldest son, Kelton, there, he's 26. He's in the Nebraska National Guard. That picture was as his troop was deploying to the Middle East just this last January, so he's still over somewhere where it's hot and sandy and dry. And then my youngest son, Connor, and his wife, Stacy. And I'm really happy to say that I'm going to be a grandpa in January. All right, now I'm going to do something a little goofy here, so I hope you'll humor with me. I know we just had a little break, but I'd like everybody to stand up. All right, this will only take a couple seconds. Just stand up. All right, put your hand over your heart. All right, now take a step to the right. Take a step to the left. All right, you can sit back down. So now you can go home and say, wow, Greg Brown uplifted us, touched our heart, and moved us. All right. So as you heard a little bit about how I got involved in this, basically 2019, I saw a news report that Selena Soul was suing the Kinetic Interscholastic Athletic Association, and she's being represented by Alliance Defending Freedom. And I basically got on the ADF webpage, found a contact us thing, sent in a contact, said, hey, I'm an exercise physiologist. I know that sex matters in sports. I know it makes a difference. Can I be helpful? I'm sure that they Googled me and looked me up to make sure I wasn't some crazy person. And I'm only 99% not crazy, I guess. But anyway, and then they contacted me back, and I met with Roger Brooks and some other folks with Alliance Defending Freedom. And so I wrote an expert declaration for Soul versus CIAC, which led then to an expert declaration for Hecox versus Little in Idaho, which has led to expert declarations in West Virginia, in Tennessee, and Arizona, going to various states to testify on behalf of protecting women's sports. And so it's just kind of expanded from this little contact to being this whole other life, it seems like. And it's crazy. It's absolutely crazy. 10 years ago, if you'd have told me I'd be doing this, I'd be like, no, you're kidding me. And here we are. All right, so here's one of the problems that we see, and this has been talked about a little bit. I appreciate Councillor Bach really bringing this up, and others bringing it up today. That's the title of an article by David Handelsman, Sex Differences in Athletic Performance Emerge Coinciding with the Onset of Male Puberty. It's the title of the article. You can see that was published in 2017. You can see two other quotes from other articles there, another one by David Handelsman, another one by Joshua Safer. And Joshua Safer is an advocate for the other side of this, very adamant in that, but stating in essence that there's no difference in boys and girls in athletic performance until puberty. All right? And so we have those statements there that lead to this, as was mentioned, whether it's World Athletics, whether it's UCI, whether it's FINA, saying, oh, if you suppress puberty before age 12 or Tanner stage 2, whichever comes first, then a male can compete in female sports. I am convinced that that's wrong. All right, that is absolutely wrong. Now, one of the things I would like to point out first off is these figures are from Handelsman's paper. And so if you look at running or jumping, all right, at age 10, the average boys are 3% faster than the average girls. And you can see it jumping at age 10. The average boys are jumping about 5.5%, 6% further than average girls. And I don't know if the average boy is faster than the average girl. Does that indicate that boys are faster than girls? Now, I understand statistically, right? When you're analyzing the statistics like this and looking at the variation and the huge differences after puberty, I can understand why statistically maybe those smaller differences before puberty don't come out as statistically significant, right? And yes, I'm an exercise scientist. We use statistics to make our decisions and everything. But one of the questions we have to ask ourselves, statistically significant versus practically significant, right? There is a difference, right? We know in sports that a 0.01% difference can mean the difference between a gold medal and no medal. So this 3% difference between boys and girls can be huge in sports. All right? Sorry, want to hold off on this for just a second. So one of our challenges, though, we have with looking before puberty is honestly a lot of sports before puberty, they're recreational. They're local, it's developmental. When was the last time you saw a newspaper article or something on the local television station about the state 8 and under track and field champion? Right? You don't see it. People don't put the interest in it as much as they do, especially once we get to the high school level when kids are competing and scholarships are on the line and state championships are on the line. So there's not as much information out there about sports competition before puberty. Again, it's very local. I don't even know if a lot of elementary schools keep records on which 4-year-old was the fastest in the mile run, right? So those are our challenges with that. But again, Handelsman has this information. One area we can look, fitness testing, all right? All of us have done this in school. We hated it, right? In the United States, you do FitnessGram. In Europe, it's the Eurofit. Different places have their fitness testing that we do. So if we look at some information here, this is German children, about 900 German children. And you can see the 9-year-olds and 10-year-olds. Notice the boys are consistently performing better than the girls on measurements of muscle strength, muscular endurance, running speed, aerobic performance. The girls are doing better in flexibility, right? Now the differences are small. Yeah, we're looking 2 or 3% difference in the 50-meter sprint. The 1 kilogram ball push, upper body strength, much larger difference there, 17% or so. Triple hop, 4% difference. But again, consistently, the boys are outperforming the girls. Now people are going to look at this and say, oh, well, that's just Germany. Oh, that's just one particular paper. That is a legitimate concern or legitimate criticism. So let's look at this one. This is from a paper where they evaluated in 30 different European countries, 2.2 million fitness tests. All right? So this means every one of these different fitness tests, there's hundreds of thousands of children measured in this. There's a definite statistical power once you start having hundreds of thousands of observations. More observations in this one paper than all of the studies on transgender individuals combined. And I just spilled my Pepsi. I need a napkin, dang it. Or several napkins, but.
Coming.
Thanks. Thank you. If it had been a Coke, I wouldn't have spilled it. Coke is too precious. Sorry about that. Mara, this is going to be sticky. Just a warning. All right. So here we're looking again. This is 30 European countries, hundreds of thousands of children in each of these tests. And again, the boys are outperforming the girls in measures of muscular strength, running speed, aerobic endurance, muscular endurance. The girls are outperforming the boys in flexibility. Well, people may say, oh, well, that's just Europe. Okay, well, let's come to another paper here. All right, so this is a paper from Tompkinson. This is looking specifically at 20-meter shuttle run, 50 different countries, 1.1 million children across 50 different countries. And you can see the outline there. That's not just Europe. That's not just North America or South America. You've got Oceania, you've got Australia, you've got Asia, you've got Africa included in this. And consistently, the pre-pubertal boys, age 9, age 10, were 3 or 4% faster in the final lap than the girls were. Now, this is a 20-meter shuttle run. In the United States, we know it's the pacer test. Other places, it's the beep test. But the boys were going like 20% more laps, all right, which is still 3 to 4% faster. So I'd say we've got some good school-based data that boys have physical fitness advantages over girls. Another criticism of this, well, that's school-based fitness testing. We all know how that goes. If your friends are walking, you're walking, right? And if your friend's counting the push-ups, maybe they add push-ups, maybe they subtract push-ups because they don't like you that day, something like that, all right? So here's another very interesting paper. Now, this paper was published in 2005. So this is not like it's brand new data. The previous paper was 2013, all right? So this is in about 700 Danish children. And I think if we look at gender roles, Denmark is pretty egalitarian on the gender roles, right? So if we're going to minimize social influence on physical fitness, Denmark might be the place to look. Well, what they did is they had these boys and girls come in, and they did a VO2 max test on them, where they put them on the treadmill, graded exercise test with the metabolic cart. That is a lab standard for measuring aerobic fitness, all right? These 6 to 7-year-old boys, the absolute VO2 max for the boys was 11% higher than the girls. Absolute VO2 max, part of it is representative of body size. We expect a larger person to have a larger oxygen consumption because they have more tissues that need to be fed. So if they took that VO2 max and measured it relative to body mass, which is typically how we're going to compare individuals. If you do a fitness test and you want to see how you compare normatively, we look at VO2 max relative to body mass, milliliters of oxygen per kilogram of body mass per minute, still an 8% advantage for the boys, all right? So even account for differences in body mass, the boys have an advantage. Now in adults, we're going to see that more like 25%. But still an 8% advantage matters. Now if they took that relative to fat-free mass, so now we're going to try and control for differences in lean body mass, the boys still had a 2% higher VO2 max, right? So we've accounted for differences in muscle mass, and there's still a male advantage in VO2 max. The other thing that was interesting with this study is they put accelerometers on the children and had them wear the accelerometer, which is a very objective way to measure physical activity. And they found for boys and girls, if they got the same amount of physical activity, the boys were fitter, which would indicate, again, some kind of biological advantage where, in essence, for the girl to have the same VO2 max, she's going to have to exercise a whole lot more than the boy does. So again, we see this evidence of male advantages for physical fitness, all right? And lest you think that I'm cherry-picking these studies or something like this, this is not a comprehensive list. This is a quick search through PubMed, 21 different papers that I came up with, dating back, I think I went back to 1985 on this, but you can go back into the 50s and find physical fitness testing between boys and girls showing that boys do better on tests of muscular strength, muscular endurance, aerobic fitness. Girls do better in flexibility. And again, so I'm not cherry-picking, and this is from across the world. Right? Now, people are going to criticize that, and they're going to say, well, that's fitness testing. And as we heard Ross say, yeah, VO2 max is not the end-all, be-all. Muscle strength is not the end-all, be-all. We have all been there when we're like, I know I'm better fit than that person. They still beat me. At least I say that to myself when I lose a local 5K or something like that. Right? So that is a valid criticism. I do think it's interesting that we look at adults and say, oh, males can outperform females, and here's the fitness testing data that substantiates that. So when you take children and say children have physical fitness testing advantages, people dismiss it as that there's not competitive advantages, but whatever. All right, so this is from the Nebraska 2023 USA Track and Field Junior Olympics. And so I've got the events lined up there on the bottom. I've got the medal count set up on the top. You can see it split for 8 and under and the 9 and 10-year-old group. Now, they didn't compete head-to-head, but if they did, taking the boys' times or the boys' distances compared to the girls' time and the girls' distances, not a single girl in the 8 and under group would have gotten a medal. I think this is an important point that we're getting to here. If those 8 and under girls didn't medal, how many are coming back the next year for that track and field competition? All right? If we look at the 9 and 10-year-old girls, okay, 1 gold medal out of 8, all right? And 3 silvers and 2 bronzes. Out of 24 total medals, the girls would have gotten 6. That indicates to me that there's an advantage there. Now, people might look at that and say, well, that's just Nebraska, right? Nebraska's marketing campaign for the state 2 years ago was, Nebraska, honestly, it's not for everyone. All right, so let's go to Arizona. All right, so we've got this challenge going on in Arizona right now. So same event, this is the Arizona 2023 Junior Olympics. All right, look at the 8 and under group. Okay, we would have had a girl getting a bronze medal in the 200, a bronze and a silver in the 400. Otherwise, 8 and under, no girls getting gold medals, most of the medals going to the boys. Look at the 9 and 10-year-old group. Again, there would be a tie in the long jump for a gold medal, the only gold medal a girl in the 9 and 10-year-old group would have received. Otherwise, 3 bronzes. So again, it looks to me like we're seeing evidence of a competitive advantage, or maybe we should say category advantage, John, all right, for males. Well, again, people might say, well, that's just Arizona, all right? I don't know what Arizona's marketing motto is, all right? So let's go to the 2023 USA Track and Field National Competition. Now, a caveat here, right? How many people are going to take their 7 or 8 or 9-year-old child across the country to compete in a track and field competition? So this is one of our challenges with the children's medals and everything, but we still look at this, and yes, we see a little more representation for girls in the medal count, but still, out of 24 medals, the girls would have gotten 5 in the 8 and under group and would have gotten 5 in the 9 and 10-year-old group. We're seeing the boys would have gotten 80% of the medals. That's indicative of me that there's some kind of pattern here. I'm not sure I can figure out what that pattern is, but there's something, right? Well, people might also look at that and say, well, those are just individual years, and doing the medal count, maybe that's not a scientific analysis of it. Again, a valid criticism. So I took the USA Track and Field Junior Olympics from Nebraska from 2016 to 2023, calculated the average throwing distance. I just put it together to kind of simplify the graph for shot put and javelin for boys and girls. Average boys were throwing 55% farther than average girls. That was statistically significant. The t-test on that was p less than 0.000000, right? You go to scientific notation to get that. All right? Same thing for the 9 and 10-year-olds. And the furthest throwing boy was 30% further than the furthest throwing girl, right? Both, and that was in the 8 and under, and look in the 9 and 10-year-olds, still 10% more for the furthest throwing boy than the furthest throwing girl. Of course, you've got an N of 1 versus an N of 1, so N of 2 total. We can't do stats on that, but still numerically different. All right? Well, what about jumping? And again, the same thing. We still see that the average boys were jumping further than the average girls in the 8 and under group and the 9 and 10-year-old group. All right? And the furthest jumping boys were jumping further than the furthest jumping girls. Here again, you might say, well, that's Nebraska. It's not for everyone. So I went to athletic.net, got the data for all of the top 10 boys, top 10 girls in all of the running events they did. So 100 meter, 200 meter, 400 meter, 800 meter, 15 and 1600 meter for 5 years. And again, lined them up, analyzed them statistically. The average boys in those top 10 were faster than the average girls. The fastest boys were faster than the fastest girls. Statistically significant when you look at the group. And again, 9% faster overall through all those running events for the fastest boys, 6% faster for the fastest boy in the 9 to 10-year-old. Starting to see something here, all right? We see the physical fitness testing, we see the individual years. Now we're starting to see statistically there's a difference between boys and girls before puberty, all right? And so if we look at the USA Track and Field youth records, all right, I'm going to call out the media on this one. Every one of these bills that has been brought up in the United States in a legislative meeting, somebody in the media should have been grabbing this. This is on the internet. This is simple to find. And you look at this record, the boys are faster than the girls in every event. The boys are throwing further than the girls in every event. These are the records, right? But instead, somebody's not doing their job in getting this information out. All right? Now, lest you think this is only a United States thing, all right? So we can also look at it, Australia, all right? See the same pattern in Australia. The numbers might be a little bit different, but again, the boys are faster than the girls. The boys are jumping and throwing further than the girls when you look at the records. I'm sure you can find this in other countries, in other places. It's harder to find. A challenge with these records, and I don't understand, the record from Australia hasn't been updated since 2016. The records for the United States haven't been updated since 2019. I understand the challenges with verifying all this stuff, but I don't know, conspiracy theory in me is starting to raise, some questions on why they're not updating these records. I want to thank boysversuswomen.com, great website, Jake Teeter there. All right, and so this is a graph that he has put together, pulling data from all over the place. I mean, he has compiled dozens of different sources of international data and combined it all to look at the average male advantage across 11 track and field events before puberty through 80 years old. And you see consistently at every age, males are outperforming females, right? You see a little dip there where the difference gets smaller, and that coincides with what they call peak height velocity, which you might call the growth spurt. Typically, girls hit peak height velocity. They're growing the fastest at age 11 and a half. That's when you'd actually see body height come close to normal or close to equal between boys and girls. But then at age 12 and a half, boys are at peak height velocity, and then you see that acceleration, just that turbocharging of the difference between males and females. But again, we see it in Nebraska, we see it in Arizona, we see it in the United States, we see it in Australia, we see it worldwide. Boys have athletic advantages before puberty. Looking at USA swimming, right? Which again, swimming, I'm not as much on my swimming science as I should be. Actually, Kim probably knows more of swimming science than I do. But again, look at the USA swimming records. Now, USA swimming only lists records for 10 and under, but the boys have the records in 18 out of 22 events by roughly 2%. Girls were faster in 4 events. Again, when you see one sex has the record in 82% of the events, you should think something's going on there. Maybe sex matters. And so, yes, some girls are faster than some boys. It's unquestionable. But on average, the fastest boys are faster than the fastest girls. The average boys are faster than the fastest girls, right? Yes, some girls are stronger, shown in jumping distance or throwing distance than some boys. But on average, the average boys are outperforming the average girls. The fastest boys are outperforming the fastest girls, right? Now, these differences are smaller than before puberty. No question about it. We're talking a 3, 5, maybe 10% difference, much smaller than when you're looking 10, 20, 30, 40% differences after puberty. But the differences are there and the differences are consistent. And again, in athletics, small differences really matter. The question is, why are these differences present before puberty? One question, does it matter? One of the attorney generals from one of the states that I've worked with said to me, from a policy standpoint, it doesn't matter why that difference is there. There is a male versus female difference. That's what matters. Explaining it physiologically isn't the important thing. I don't know enough about the law to say that that's correct or not, but okay, so before puberty, boys, before puberty, boys have about 10% more lean body mass than girls. Lean body mass, which is largely muscle mass, that's the engine that drives athletic performance. The skeleton, that's the frame and the body work. The heart is the fuel pump, right? It all comes together. The lean body mass is really the big engine. If we see a 10% difference in lean body mass favoring the males, we would expect they should have an athletic advantage. All right? There are slight differences in the pelvis shape between boys and girls at 8 years old. Slight width difference in the, I have to remind myself there, the ischium and the acetabular regions. So basically the ischium is the part you sit on, the acetabular regions, that's the hip socket. Differences between boys and girls that would favor boys for better running mechanics or faster running mechanics. I shouldn't say better, right? It's all good. It's just some are faster, right? Favor for longer jumping performance. There are slight but still present differences in lung size, lung function. There's debate whether how much lung function influences athletic performance, but the higher VO2 max in boys is supported by a higher maximal minute ventilation. Right? And slight differences in cardiac function favoring boys before puberty. So we can explain those differences physiologically. Now, of course, people are going to come back and say these are social factors, right? Well, if they're social factors, how is allowing trans girls into girls' sports going to alleviate those social factors? I don't know how allowing a male body into female sports is going to suddenly erase social factors that disadvantage female bodies. All right? And so I wish I could take credit for that top quote that female athletes are not simply smaller, less muscular males. That was McManus and Armstrong in 2010 on their paper Physiology of the Elite Young Female Athlete. But those differences are present before puberty. All right? And then I think we all know this, but it's kind of crazy we have to say this. Boys and girls are different before puberty. It's not like at puberty suddenly a boy grows testicles and a penis, right? And a girl grows a vagina. They're there beforehand, all right? Puberty doesn't make a girl grow a uterus, all right? Changes how things work a little bit, but the anatomical differences are there, and so are the physiological differences. Smaller, but present. Which brings up the question of puberty blockers. And again, I think this was well addressed earlier. I do have 2 particular studies I want to point out on puberty blockers. But the bottom line on this, we have no idea how puberty blockers affect physical fitness or how they affect sports performance. The research hasn't been done. I don't know that I could do the research. Honestly, I don't think I could ethically for myself. Let's take an 11-year-old block normal, healthy puberty and see how it changes their push-up performance. Just couldn't do it. All right, so the first paper, this is actually from 2018. This is Claver, and they looked at trans girls, trans women, basically over 8 years of puberty blockers and then the cross-sex hormones. Before treatment, now notice that about 14 and a half years old is when they started puberty blockers on these children. The trans girls, trans women, male bodies had more lean body mass. They were on puberty blockers for 2 years, and you see a reduction in lean body mass, but still had more lean body mass than comparable girls, comparable females. At age 22, so basically 8 years of puberty blockers and then cross-sex hormones, the male bodies still have more lean body mass. And lean body mass is very important for athletic performance. And then Ross mentioned this paper earlier today. This one just came out this year, where they looked at growth in body height from the start of puberty blockers to age 22, basically. So the white line there, that's showing the projected growth, which it's an estimation, right? You put some factors into an equation, you get an estimate of how they should grow. And then the yellow line there represents the measured growth. This particular paper, and this is the only one we've really got on this in trans girls, there's an accompanying paper looking at trans boys that shows basically the same thing. It looks like puberty blockers slowed down growth in height. But once they were then put on, in this case, estrogen, growth accelerated. And so by age 22, they were the same height as they would have been, at least estimated, without any puberty blockers or cross-sex hormones, right? I think it was in Jurassic Park, right? Life finds a way. I think life finds a way, right? Now, again, can we say conclusively, oh, well, lean body mass improves sports performance? Well, yes and no, right? I mean, we know lean body mass is an advantage. We know body height's an advantage. And the bottom line is we don't see the erasure of the male advantages in lean body mass and body height, right? Those are not eliminated. So really 3 closing points here. The first one is that there are important biological differences between males, boys and men, and females, girls and women. And those differences are present before puberty, right? Second important point, the sex-based differences give males inherent athletic advantages, right? Even before puberty. And the current evidence indicates that having a transgender identity, with or without puberty blockers, testosterone suppression, estrogen administration, cross-sex hormones, doesn't seem to erase the male athletic advantages. Therefore, female sports should be for females only. All right. Thank you. I appreciate it. And again, Mara, I'm sorry about the spilled Pepsi. And thank you, everybody. I'll turn the time over to Mara.